Hey everybody, this is Miss Eisencraft, and I'm here to give a little explanation about the new activity we're pushing out today about quadratics. It is, if we were in the classroom, it would be a stations activity. So I'm just going to show you a similar type problem, so you'll feel maybe a little bit more confident answering the questions. I think there's 4 problems or 4 stations that ask multiple questions about the same problem. Okay, so basically you're just really needing to read the graph. So here's an example of what you might see. It says the graph on the right shows a ball's height above the ground over time. So even though it's not labeled here, the bottom is our time. So let's go ahead and, oh, yes, it is labeled. Where did that come from? Okay, thank you. And then the y-axis is the height. Okay. So the first question says, how high above the ground, so we're looking at the y values, was the ball when it was kicked? So that would be at time 0. So when it was kicked, that's at the very beginning of the situation. So that would be time of 0. So when t equals 0. So you're looking over here at time being 0. How high was the ball? Right here. So at time 0, it looks like it was 2 feet above the ground. So this part's not even really part of the graph. 2 feet. Next it says, what is the ball's maximum height? The height of the graph does represent the height of the ball. So we're going to look at the very top point. It looks like it's up here a little bit, around 16 feet is the highest it goes. At what time does the ball reach its maximum height? So this isn't perfect, but it looks like between, right before 2 seconds. I think the ones on the station might be a little bit easier to read. So we're looking right here. Okay, if you drop it down, about 2 seconds. Okay. The next question, at what time does the ball hit the ground? So now we're looking again at our time axis right down here. And at what time does it hit the ground? That would be when the height is 0. So hitting the ground is when height is 0. So 0 for height is right here. So we're looking at this. And it looks like it takes just about 4 seconds. Well, let's just write almost 4 seconds. Okay, next. Determine whether the ball is still going up or falling down at each of the following times. So we're just going to be looking at some spots on the graph along the what we usually call the x-axis or our time axis. Okay, so at 0.5 seconds, what the heck is happening to the ball? Well, it's still on its way up. At 1 second, still heading up. At 2 seconds, it's starting to descend. 3 seconds, down. 3.5, still going down. And 1.5, fancy pants, 1.5, still going up. All right. Hope that's pretty self-explanatory. Good luck on the station activity. And if you haven't already done, will it hit the hoop? Try that one too. All right, guys, talk to you later. Bye.